Greetings and welcome, internet friends. Mr. Waddy here, going over 10.2 probabilities of independent and dependent events. Here's some of the homework for you. So, tell whether the events are independent or dependent. Explain your reasoning. And this, by the way, might be slightly different on the online version of Big Ideas, but same kind of question. You roll a six-sided die and flip a coin. All right, and so the possible outcomes when rolling a six-sided die, right? 1, 2, 3, 4, 5, 6, and then flipping a coin, right, are going to be heads, tails. And so probability of getting a 4, right, is what we would consider success on the die, and the probability of getting a tails when flipping the coin. And so what we have to consider is, does the first outcome somehow change the possible outcomes for event B? And the answer is no, right? Like if I roll a 4, it doesn't change that, like, now I can only flip heads, roll heads. Heads will roll is what they say. And so no, it's not going to affect it in any way. And so these are independent events, because it doesn't, the first event does not change the outcome of the second event. All right, let's take a look at another one. You have 1 red apple and 3 green apples in a bowl. You randomly select 1 apple to eat now and another apple for your lunch. All right, and the key word is another. Use a sample space to determine whether randomly selecting a green apple first and randomly selecting a green apple second are independent events. And so sample space could be like red, green, or I guess I'd have to do like RG1, RG2, RG3, RG4, right? That's a possibility. I could also have G1 with G2, G1 with G3, G1 with G4, and G1 with red. I could also have G2 with G1, right? And so I've got a whole bunch of different possibilities. And I could have G2 red, and then I could also have the same for G3 and G4 with similar lists resulting. And so determine whether selecting a green apple first and randomly selecting a green apple second are independent events. Well, based on the use of the word another apple and the fact that you're eating one of them, these are going to be dependent events, right? It's going to change the possible outcome. So getting one, or how many, let's do it this way. How many, there are 3 green apples, right? So for the first choice, right, probability of event A, the first choice, there were 3 green apples, and there was out of 1 and 3, so that's a total of, right, 4 apples total. So 3 out of 4 was my first choice, and then the probability of event B, and later on we ended up saying probability of B given A. Well, one of the issues is there are no longer 3 apples. I ate one. And so now there are only 2 apples that I could select from that are green. And there are no longer 4 apples to pick from the whole group because one's been eaten. There are only 3 remaining. And so if I end up multiplying those, oh, the 3s actually cancel out. The 2 and the 4. 2 goes into 2 once and into 4 twice. Looks like I end up getting a probability of 1/2. Right, and so So yeah, the probability would be 1/2 as far as the likelihood of this occurring. Now, I'd already said they are dependent because I didn't replace the green apple that had been eaten, right? It changed the total space of outcomes. It also changed the number of successful outcomes in this case. And so, yeah, it's no longer independent events. Let's keep going. Question 11. Play a game that involves spinning the money wheel shown. You spin the wheel twice. Find the probability that you get more than $500. So probability, I'll just say greater than 500 on your first spin, and then go bankrupt on your second spin. Now, one of the things to consider here is that, well, let's figure it out first. So more than $500. So, all right, I'll start counting from here. So I'm counting the number of locations that would give me more than 500. So 1, 2, 3. Man, it's hard reading upside down. 4, 5. Now it said more than, so I can't include this. 6, 7, 8. And so there were 8 possibilities successfully getting more than 500. And the total space was, did it say? No. They're going to make me count. All right, get ready for engaging internet content. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Aha. And so that's the probability of getting greater than $500 on that first spin. Now, in getting whatever one of those outcomes, although actually now that I think about it, does Wheel of Fortune like remove a prize once you've earned it? Like if I spun and got the $5,000, would they take that sliver, that slice, that sector out of the wheel before I spin again? It doesn't seem to indicate that here. And so I'm going to say that you could land on 5,000 twice. Okay? And so this is like a with replacement scenario. These are going to be independent events. So getting more than $500 on the first try will not change the possible outcomes on the second try. Now, probability of bankrupt. Now, we're going to call those successes, even though in real life, hopefully you don't want to be bankrupt. There are 2 of them, and that is out of 24. So, like I said, it didn't change the space of possible outcomes. And so 8 over 24 is the same as 1/3. 2 over 24 is the same as 1/12. So that's equal to 1 out of 36. Right? And so it is unlikely for this particular combination to have occurred. Right? So there you go. Let's keep going. Ooh, looks like word game. We'll call it Scrabble. Has 100 tiles, 98 of which are letters and 2 of which are blank. The numbers of each tile, the numbers of tiles of each letter, are shown. You randomly draw one tile, set it aside. Ooh, randomly draw one. And then, set it aside. You don't put it back in the bag. And then randomly draw another tile. Find the probability of events A and B both occurring. Okay, and so set it aside. This is going to be dependent. Classic dependent. Right? Set it aside is the same as the phrase without replacement. And so I've changed the number of tiles that are in the bag when I get to draw it the second time. So what's the probability that the first tile is a consonant? Okay. Oh dear. Now this is going to mess me up because of the sometimes Y thing. Well, I'm not. Oh, burgers. All right, let's figure this out. So probability of event A and then I'm going to multiply that by the probability of B given A has occurred. Okay? And so the number of successful ways to get a consonant, it's 2, 4, 8. Let's see, I'm doing math here. 10, 13, 15, skipping that, 16, 17, 21, 23, 29, no, 35, 39, 45, 46, 48, skip that one, 50, 52, 53, I'm going to skip that one, and 54. So I'm saying there are 54 consonants excluding the Y, all right, out of a total number of, oh, fortunately, they already told me 100 tiles. Good, so I don't have to add them all up. And now, how many of these are consonants? Oh. Well, I've already drawn a tile and set it aside, and whilst I have purple here, I want to point out there are now 99 tiles in the bag. However, the selecting a consonant did not change the number of successful ways I could draw a vowel. All right, it changed the total outcomes, but the numerator, the number of vowels, they're all still in there, right? And so theoretically I could do 100 minus 54. There's 46 remaining tiles. Get rid of the 2 that were blank, because those don't count as vowels. And so 46 take away 2, 44. I'm going to call it 44. All right. And tell you what, do I have my calculator around here? Where donde is? Ah, here it is. Here it is. I could reduce the 54. Oh, I could actually reduce both of these. Can't I? Is 54 divisible by 4? Nope. No. So let's see. So this is the same as 27 50ths. 11 goes into both of these, so that's the same as 4 9ths. Can I cross cancel? 2 goes into 4 twice, and into 50. Let's see. 25 times, and 9 goes into itself once, and into 27 3 times. And so I'd have 3 times 2 across the top is 6, 25 times 1 across the bottom. I get 6 25ths, which is the same as 24%. And so this 24% is the probability of randomly drawing first a consonant and then a vowel. Now, if I allowed for the order being the other way, it technically would increase that probability, right? If I sought the possibility of including vowel first and then consonant, but that's not what we were asking. We wanted this exact way. Your results would be slightly different if you dealt with Y differently, or blanks, if somehow you believed that blanks could have been counted in either group. I don't know. Let's see, last question. Events A and B are dependent. The probability of B, well, let's see, let me write my little equation. So probability of B given A, if I multiply that by probability of A, that's how I find probability of A and B. Okay? In this case, now this is just kind of be substitution in algebra by the looks of things. I know the probability of A and B is 15%, 0.15. I don't know the probability of event A occurring. And I know the probability of B given that A had occurred. And so I plug it in and I solve. So it's currently being multiplied by 0.06. So I would divide both sides by, or 0.6, not 0.06. And so I'm going to get probability of A equals 0.15 divided by 0.6. I get 25%. Boom. Got him. Very good. All right. Well, anyways, thanks for watching, Internet friends. Hope you all have a great day.